Not in South Africa, basically. In my language, that is, it's a click, yes. So, no, don't worry, yeah. My name is Xolani, and I'm from Roth University, and my presentation title is Recreational Angling selectively removes high-performance physiological phenotypes from fish populations. Okay, so the previous speakers have already unpacked nicely the crisis of climate change, and so here I just want to emphasize that both climate change and exploitation or recreational angling place marine fish populations under significant pressure. So climate change on the one side leads to changes in physical and chemical properties of seawater through changes in temperatures, salinity fluctuations, reduction in pH, which makes the water more acidic. And all these have a direct influence on the physiology of fish. Now, while more emphasis has been placed on long-term global changes in in average sea surface temperatures, there is a growing recognition of the importance of short-term localized variabilities. And these small-scale fluctuations are becoming more intense, and they are intensifying. And this is they may have serious or major physiological consequences on marine fish species. Now in South Africa we have these two major currents, the warm algalas on the east and the cold benguela on the west. And they contribute to the highly variable temperatures that we observe in our coast. And in addition to that, we are having these warming regions and cooling regions. The warming is associated with marine heat waves, while cooling is linked to upwelling events. And these two are projected to intensify under future climate change scenarios. And this is concerning because temperature is one of the most influential drivers of fish physiology, and these changes may pose serious implications for the metabolic performance of fish. Exploitation, on the other side, reduces biodiversity, also reduces abundance, and over time you would find that the system will have these fish that are reproducing while they are relatively smaller in sizes. But fish do not experience these stressors in isolation. So there is a need to understand the synergistic effect of these crises, and in our case, climate variability and exploitation, and to also understand how they influence the physiology of fish. These are two different studies conducted on the same species, collected from the same protected area and exploited area. And on the left, you will see aerobic scope capacity, which represent the energy available for essential life processes like growth, movement, and reproduction. And on the left, the study used accelerometer text to estimate the field metabolic rate. And what we see from these studies is the clear difference in the metabolic performance or metabolic physiology of the fish, that there is a difference between the exploited and protected population. And furthermore, Duncan et al. Suggested that exploitation may influence the climate resilience of fish populations through removing high-performance metabolic phenotypes. But we also need to understand how that happens, the underlying mechanisms. And the study was done at a population level, and that is good, but we also need to understand the individual variabilities, because different individuals may respond differently to these stressors. And this brings us to the aim of our study, which was to augment our knowledge on the impact of exploitation and thermal variability on fish physiology. And we did this by comparing the individual metabolic physiology of a marine fish species collected from a protected and exploited area. And so we used the same species, Chrysoblephus laticeps. This is a species endemic to South Africa. It is a highly resident species, and its distribution spans across, it starts from Cape Point in the Western Cape to Port St. John's in the Eastern Cape. It's one of the important recreational and commercial fishery species in South Africa. So we collected individuals from the exploited, which is color-coded red, Cape St. Francis, and some individuals from 18 individuals from Kokama Marine Protected Area are color-coded in blue. So it was 20 from the exploited and 18 from the protected. And these two sites are located on the south coast of South Africa, and they have thermally comparable conditions. Now, because our interest was understanding how fish respond to thermal variability at an individual level, we tagged these fish with visible elastoma to identify them, and we exposed them using repeated measures to these three test temperatures, 10 degrees, 16, and 21. And we measured oxygen consumption rate, which we use to estimate the standard metabolic rate and maximum metabolic rate. For maximum metabolic rate, as you have heard in the previous talkers, we chase the fish around and put it back in the respirometry chamber to measure the oxygen consumption. We did temperature and mass correction to account for individual differences, and we calculated the aerobic scope by subtracting the standard metabolic rate from the maximum metabolic rate. And we used linear mixed effect models with fish ID as a random term. And these are the results from our study, and we can see here, again, those blue is an unexploited and red is the exploited. I just want to draw your attention to B and C, where we found significance in temperature, site, and the interaction between temperature and site. And so what these results show us in B and C is that the individuals that are coming from an unexploited population, in terms of their metabolic physiology or maximum metabolic rate and aerobic scope, they had significantly higher metabolic rate compared to the individuals that were collected from the exploited site. We further classified our individuals according to lower performers, intermediate performers, and high performers using the method by Bailey et al., where 1 point meant that the fish is a lower performer, 4 points meant that the fish is a higher performer, and the in-between was the intermediate. And these are the results from our study. And what we see here is that the unexploited site, there were about 42 individuals in our study that ranked as high performers, while none of the individuals in the exploited ranked as high performers. And as you can see also, the low performance phenotype, about 18% of individuals in the unexploited ranked as lower performers. And what we see also is that diversity in the metabolic phenotype of fish within the unexploited or the marine, the protected area. From these results, we can see now the comparison between that study that was done at a population level, and we did our study, conducted our experiments at an individual level. We see similar patterns that in terms of metabolic physiology, the fish that are coming from a protected area have significantly higher metabolic phenotypes compared to fish from the exploited. Now, our study results are on the left. In this case, here I just want to draw your attention to these two different studies where they use accelerometer tags to measure the metabolic activity of fish in the wild. And so if you see C and D, these graphs, what they show us is that, so the blue is the protected and the other color is exploited. And so in these two graphs, you can see that across all or across different test temperatures, the individuals from or the protected area had a significantly higher maximum activity compared to the exploited. Now, this is another study that looked at individual variability, but these individuals were collected only from an exploited site. And what is interesting with this study is that they linked physiology and behavior, where they saw that they observed that the high performance phenotypes tend to have a bold and aggressive behavior. So what are the implications then of all this? Now, in a system where you have diverse metabolic phenotypes, you have high thermal performers, you have low thermal performers. What exploitation does is it selects against high thermal performance, as we have seen previously, that these are the individuals that are aggressive and bold. And so as you can see that the high thermal performers are captured across wide temperature windows. As you can see, even in extreme cold and warm, they are still caught, while the lower performers are caught within a narrow range of temperatures. And over time, you may find a population that is dominated by the lower thermal performers, that is not even diverse in terms of physiological phenotypes. And this may weaken the resilience of this fish population under future climate change scenarios. Now, just to draw to a close, our study does show that fishing does tend to remove high performance physiological phenotypes from the population, and that climate variability amplifies this selective pressure. And so our study and the previous studies, they do show us the significance of spatial protection. So protecting physiological diversity is essential for maintaining healthy and stable populations in a rapidly changing environment. Thank you.
Good stuff. Time for questions. So Dave and then Robert.
With this species, do you know how much movement there is during the year to spawn? Is there any kind of are they resident and spawn right within the protected areas and don't move out? And if that's the case too, do you expect or see any gene flow from inside the sanctuary out?
Okay, so they are a highly resident species in nature. There are studies that have looked at the spillover effect, especially in the Hochhammer Marine Protected Area, where they looked at the individuals, that there was a spillover effect, that individuals are going outside or recruiting also outside the marine protected area. But in terms of the gene flow, I'm really not sure about that, but it's one of the interesting things to maybe look at in the future.
Fascinating work. Two questions. The assumption that you catch these high performers selectively, have you ever done tests to show that? First question. And the second, could there be a density feedback in the MPA? So there are other things that are different between the MPA and the open site that also influences metabolic rate. Could that be, or can you exclude that?
Okay, so
Can you speak into the microphone, please?
okay, thank you.
There you go.
Thank you. So yeah, in terms of testing and catching them, no, we haven't done that. So the work is more of theoretical, but also with the empirical evidence from laboratory studies and field studies, as I showed, that accelerometer studies. And the second question was about.
So let's say the MPA has other differences.
Okay.
In fishing.
Okay.
For example, more fish. And could this affect the metabolism independent of fishing?
Okay, I think there may be other factors, but in this study we did not consider those factors particularly. We were interested in looking at the individual variability. Given that there are studies that have used the same species and looked at the thermal variability at a population level, so the main interest was looking at the individual level and comparing the protected and the exploited population. But I think those are really good thoughts to ponder on, and yeah, we will consider them in the future.